Hi, so this video is on using theorems of lines and transversals. So in the last section, section 3.1, we talked about parallel lines cut by a transversal, and we talked about the resulting angle pairs that come out of that. So today we're going to be using those theorems, whether you know they were theorems or not, they are, that if you have those parallel lines cut by a transversal, it makes different angle pairs that are either congruent or supplementary. And today we're going to be using those theorems to find missing angle measures given the set of parallel lines. Or we're going to decide whether or not two lines are parallel based on the given angle measures. We're going to be able to identify whether or not a quadrilateral is a parallelogram and find missing angles on a parallelogram. Okay? So those are our goals for today. So we got to think about, what does the given information tell us? If it's given that two lines cut by a transversal are parallel, then we will know that the corresponding angles, the alternate interior angles, and the alternate exterior angle pairs are congruent. We will also know that same side or consecutive angles are supplementary. Okay? So if we know the lines are parallel, then we know these things are true about the angles. But we can also come at it from the other direction. If we know that corresponding alternate interior or alternate exterior angles are congruent, so we're given that the angles are equal, then we will also know that the lines are parallel. So we can start out with knowing the lines are parallel and say certain things about the angles, or we can say things, if we know things about the angles, then we can say the lines are parallel if they fit those relationships that we have talked about. Okay. So similarly, if it's given that same side angles are supplementary, then we'll know the lines are parallel. But vertical angles are always congruent, regardless of whether the lines are parallel, as well as linear angles are being always supplementary. Okay, so those ones do not depend on the lines being parallel, which we talked a little bit about yesterday. All right, so our first example here, given that the lines are parallel, so we know the lines are parallel, that's given information, and that the measure of angle 2 is 70 degrees, we want to find the measure of all the other angles. So on these diagrams, we really do only need to know one of the measures in order to find all the others. So we're given that this one is 70 degrees, but then I know that this angle 4 would also be 70 degrees because those are vertical angles, and vertical angles are always congruent. Angle 4 and angle 6 are alternate interior angles, and those are congruent if the lines are parallel. And then 6 and 8 are also vertical angles. All right. Then we see that angle 1 and angle 2 together should be 180 degrees because they make up a line together. So this one's going to be 180 minus 70, which is 110. And then 3 is a vertical angle, so that will be 110. And then 5 is an alternate interior with 3, so that one's going to be 110. And then 7 is a vertical angle with 5, which makes all of those either 110 or 70. Okay. On this one, we want to find a value of x that will guarantee the lines are parallel. So it's not really telling me if the lines are parallel or not, but it's asking me to find the value of x that would make them parallel. So because these two angles, 120 and 2x, because those are alternate interior angles, then I know that they must be congruent for the lines to be parallel. So because of that, if I want to find the x value that will make them parallel, I set 2x equal to 120 and then solve for x. So if x equals 60, then these two angles will be congruent, and if these two angles are congruent, then the lines are parallel. All right, so here we have 3x and 60. We want to find, or we're given that the lines are parallel, we want to find what x would equal. So if we know the lines are parallel, then we know that 3x and 60 have to be congruent because they're corresponding angles. So we just set them equal. Divide by 3, and x equals 20. Okay, let's try another one. So on this one, we have 2x and 80. Those are same side interior or consecutive interior angles. And because of that, I know that they're going to be supplementary. So if I take the two angles, 2x and 80, and add them together, I know it's going to have to equal 180. And then I can go ahead and solve for x by subtracting 80 from both sides. So 2x equals 100, and then divide by 2. So x equals 50. If x equals 50, then these two angles are going to be supplementary. So, and because the lines are parallel, I know they are going to be supplementary. On this one, we are going to solve for x and y given the lines are parallel. The first example doesn't have a y, the second one will. So x minus 20 and 70 are alternate interior angles. And when the lines are parallel, alternate interior angles are congruent. So I know these are going to have the same measure. So for number 3, I can set 70 equal to x minus 20. And that will give me what x equals. So add 20 to both sides, and x equals 90. Okay, this number 4, I'm going to find both x and y. So I'm going to start, you could start by finding y. I'm going to start by finding x. 3x minus 6 and 7x plus 16. I want to use both equations that have x in them so that I don't end up with an equation with two variables. So I'm going to use both of these angles, and because they are consecutive interior or same side interior angles, I know they're supplementary. So I know that 3x minus 6 plus 7x plus 16 should equal 180 degrees. So I'm going to simplify this side of the equation before I try to solve for x. So 3x plus 7x is 10x. Negative 6 plus 16 gives me plus 10, and then equals 180. So now I can find x by subtracting 10 from both sides. So 10x equals 170. Divide by 10, and x equals 17. Okay, so now I have x, now I can find y. So I can find y a couple of different ways. I can either use these two expressions for y, because I know these two angles are equal. So I could set 9y plus 18 equal to 7y plus 24. Because these lines are parallel, these alternate exterior angles should be congruent. So that's one way to set it up. Another way is that since I know what x is now, I could replace the x here with 17. So 3 times 17 minus 6 would give me the measure of this angle. And then I know that that is equal to 9y plus 18, so I could set those equal. I'm going to go ahead and solve it this way. So I'm going to subtract 7y from both sides. So 2y plus 18 equals 24. Subtract 18 from both sides, and then 2y is equaling 6, and divide by 2. So y is equal to 3. Okay, so y is 3 and x is 17. All right, so on this one we want to find the value of x that will guarantee the lines are parallel, which means since these two angles are corresponding angles, they will have to be congruent for the lines to be parallel. So on these ones I'm going to set them equal. So basically all of our angle pairs will either be congruent or supplementary. If they're congruent, set them equal to each other. If they're supplementary, put a plus in the middle of them and set them equal to 180. So here I'm solving for x by subtracting an x from both sides. So x minus 45 equals 30, and then add 45 to both sides, and x equals 75. So if x is 75, these two angles will be congruent, which means the lines will be parallel. All right, we want to find y that guarantees the lines are parallel. These two angles are consecutive interior or same side interior. So I'm going to add them together because they should be supplementary, meaning if I add them together, I should get 180. So solving this, first I'm going to simplify 64 plus 16. So 4y plus 80 equals 180. Subtract the 80 from both sides. So 4y equals 100. Divide by 4, so y equals 25. Okay. Now, we talked a little bit about parallelograms in the previous section. So we're just going to quickly go through this. Parallelograms have opposite sides that are parallel. They also have, sorry, I'm just going to skip ahead here. They also have the following properties. So property 1 is that opposite sides are congruent. So if this side right here were 10 inches, this side here would also be 10 inches. They have opposite angles are congruent. So if the angles are the ones that are kind of kitty corner from one another, they are going to be the same measure. Likewise, this angle and this angle are going to be congruent. And then consecutive angles are supplementary. So consecutive angles are right next to each other on a line. So like C and D are supplementary. And if I add those together, I should get 180. Same thing for D and B, A and B, C and A. Okay, any two that are next to each other will be supplementary. So keeping those properties in mind, we can now use those to solve for side lengths and for angles in parallelograms. So because I know this is a parallelogram, and I know that this side is 58 and this side is 2a minus 12, I know that those have to be equal because opposite sides in a parallelogram are congruent, so I'm going to set them equal to each other to solve for a. Now this is actually asking me here to solve for the side length. It's not just asking me to find a, it's asking me to find the side length. This one I already know is 58, right, because I know that one's 58. But this will help me solve for a, and when I have a, then I can find this side length as well. So I'm going to solve this for a by adding 12 to both sides. So 2a equals 70. Divide both sides by 2, a equals 35. So now that I know what a is, I can find this other side length just by plugging in a. 35 for a. So 3 times 35 plus 4. 3 times 35 is 105, and then 105 plus 4 is 109. So obviously, this is not drawn to scale, right? Because this side is shorter, and this side is longer. This one's 109, and that was 58. So it's generally a good idea not to consider your diagrams as drawn to scale. Okay. Number 2, solve for the angle measure of the following parallelogram. I have one angle here that is 106. This is kind of cut off a little bit, but this angle down here is 106. This one across from it is 3x minus 2. So those are opposite angles, so I know that they are going to be equal to each other. And then this is also asking me to find the angle measures. I know that one's 106 because they're opposite. I can then plug in x once I find it to find this other angle. So if I add 2 to both sides, I'm going to get 3x equals 108. Divide both sides by 3, and x equals 36. So now that I know x is 36, I can plug it in here. And that would give me 72 plus 2, which equals 74 degrees. Okay. Now notice here that also these two angles that are consecutive, they should be supplementary. So actually I could have bypassed using any of these expressions and just said, well, if this one's 106, then I know this one's 180 minus 106, so it would be 74. So those are our properties, and this is going to help you on the 3.2 assignment. So good luck on that, and if you have any questions, let me know.